Welcome to the second lab, the production lab for manufacturing and metals. You can smell the metals here. The smell of metal and the thing that goes with it is different than wood. We can immediately recognize different smell and different touch and different feel, different experience. And here we have Haizhou. He will introduce us to everything.
So,
we'll give him a hand first. Very good.
My name is Haizhou Li, and I work in the production lab as a graduate assistant. So, first thing I want to tell everybody is when we get into the production lab, what's the most important thing is wear your safety glasses. So this is the #1 safety rules when we work in the production lab. Even you already wear glasses, you still required to wear safety glasses, because when you look at the safety glasses, there is a certain standard made for the safety glasses we work in the production lab, which is Z87 class. And if you look at your glasses, if your glasses also labeled as the Z87, so you are not required to wear safety glasses. But if your glasses is not a Z87 standard, so you still need to wear safety glasses. And the second thing I want to talk about is always safety is the most important thing. So when we work on the production lab, if you are not very familiar with the equipment here, so always ask for the GA or the professor first. Ask for their assistant before you started your work. And the third thing is every machine here, they have different kind of tolerance. Like for example, that hydraulic shear. So the maximum, that is a hydraulic shear. So you will see some of the machines here, it labels, it says use a quarter or less flat steel, no round stocks. So every machine has their maximum and minimum standard for the certain work you're gonna do. And I remember you asked about the drill difference in the construction lab with the production lab. Like very easy, you can tell like the color is different.
The color is different, yes.
Yeah, I think this is the easiest way to tell the difference. They probably have more certain requirement for the metal work and the construction work. It requires you to do more research. So
any difference in the tip, as someone mentioned?
Yeah, also a student mentioned what's the difference from the tips. So through my observation, there is no big difference. But I remember one student asked me if they're different from the grooves. So you can see there is a difference from the grooves. So there is I think they designed like this. There has a special reasons. So you also can dig around to these kind of areas.
Do they have any letters or initials written somewhere?
Yes, they usually the size and the material and where they made it will be stamped in the bottom of the drill. If you look close, you will see.
Yes.
So you will notice this drill, we always clamp in the bottom, right? So you will not tell very clear what size is it already. So I think this is a very good research directions you can do. Maybe we can laser print the size in the groove, so it will protect the stamps. You still will see it after a long time of use.
Very good.
Yeah. So we will.
And we have we have different sizes here.
Different sizes. Yeah, we have different sizes of drill for different kind of purpose. And if you want to look at the drill, we have more drill here. So this is a bigger size drill press. This is an extra large drill press for different kind of purposes. Like here has a lot of drill according to the design and the size you want drill. We use different kind of drill.
Come here, this was the picture here.
So here has a more heavy work.
Oh, look at that.
Yeah.
Look at that.
All different kind of drills.
Different size of drill.
Yeah. Also, I want to show you like, anyone know what's this? What's this called and what's the purpose? So this called the rim. So after you drill it, you use the rim to make the hole more smooth and more accurate to the size.
Can we see the cross section of it, please? The cross section.
Like this.
Okay. Looks like this. Very good. Very good.
So when we do the tool, I think we should start it at the lace. So anyone have experience with lace before? Yeah, what kind of lace you use back in your country?
It's a long back, I do not remember correctly.
Okay. What?
Universal lathe machine with the 4 chunks.
Oh.
4 chunks, yes.
Oh, 4-jar chuck.
Class.
Do you know like how to set a 4-jar chuck?
Yes.
Oh, really? I never used a 4-jar chuck before. As I know from Dr. Cloud, is a 4-jar chuck you need to set each jar like separately to tie to the metal stock.
You work with that? Very good.
So I want to, this is a very standard lace we are using in the production lab.
How do you spell the word lathe? L-A-T-H.
L-A-T-H.
Very good. Nice. Very good.
So, you see this lace, we have, this is called carriage, and this is a cross feed, this is a compound slide. So, this is a tool, lace tool we usually use for the face the metal stock, and the tool is made from the high-speed steel. It's not a normal steel. Usually, when you look at the drill or the lace tool, you will see there has a stamp that HSS, which stands for high-speed steel. So I want to show you a little bit how we use the lace to face the metal stock here. So everybody wear your safety glasses. Power feed, so it go through it at the same speed.
Now here is why you talk about safety glasses.
The chips. So you see, after I face the metal stock, it will be smooth. This is just something basic you will learn if you take the machining class.
Now, is there any way to smooth the sides of it, because sometimes it has some sharp edges?
Yeah, we sometimes we just use a lace tool.
Also, okay.
Yeah, to clean the edge, so it will be smooth, not hurt you. And Second thing I want to talk about is the metal monster. So for this machine here has a metal punch. So when we work at some metal sheet, we can use a punch to punch different shapes. You know, sometimes if you want to drill a lot of holes, like in a metal sheet, it's a lot of work if you use a drill, because every time you need to clamp it and then unclamp it. So if you use the punch, just punch it very fast. And also the punch comes with different size and different shapes. For example, like this shape, we probably can make a log. You know, something come here and put a log here, right? So here has also for this metal punch, here has a shear. It can shear different shapes. For example, we can shear the metal sheet, and it also comes with like the maximum. You can see the some of the standard here, and it also can share different shapes, like this square shape and also round shape. For here, you also can share the angle iron, and this part you can share something square. For example, we can share something like that. And this is a bandsaw. It works the same purpose as a bandsaw we saw in the construction lab, but this is for the mostly for the metal work. So you see the round stock I use for the lathe to face it. We can use the bandsaw to cut it. So for the bandsaw, it also have the minimum size we use the bandsaw to cut. For example, you know there is a teeth in the bandsaw, so it should when you cut some metal, you cannot cut a metal sheet use a bandsaw, right? You need to use a hydraulic shear. So the bandsaw, when you cut some round stock or angle iron or something, so at least three teeth. You see here has teeth. At least 3 teeth have to touch the metal you are using. You want to cut, okay? So it's very important to learn like some of the specifications for every kind of machines before you start your work, so you all get to know the machines and how you use it. Yeah.
And while you're using a tough machine like this, you still need brushes like that.
Oh, the brushes is used for clean the chips.
So part of the tool, I mean.
Yeah.
Tools, okay.
And another one here is the hydraulic shear. So we can use a shear to shear different kind of metal sheet. It can be like this is aluminum metal sheet. Also, you can shear the steel metal sheet. So you can see here it's maximum is a 1/4 inch. So this is probably 1/8, I will say. And I will show you how to use hydraulic shear. So first, we turn to turn off and push to stop. So this is a very special design because when you use some switch, you probably think it's push and it start, and pull to push to start, and then push again, right, to stop it. But this is different. So you pull it to start, and if have emergency happens, you push it and it stops immediately. So when we pull it, and so here has a rake. You can adjust the rake up and down, according to the thickness of your tool, the metal sheet, you need to shear and then press this button. So, let's see. And every machine has a guard. So the guard is very necessary. We can ask Shaolin to talking about why the guard is so necessary. He has experience with table saw, right?
What happened?
Oh yeah, well, a majority of machines need guards because some material, like for example, in my lab with the table saw, we didn't have a guard on the table saw, which potentially could lead to the material getting kicked back at you. Now that never happened in the lab, but it's potentially can happen. And so, like a majority of machines have guards on them to prevent things like that happening. So like in my lab, we use a guard on the table saw to prevent kickback. Because if a piece of wood kicks back at you real fast, you'll probably, get a splinter or get punctured. And the same goes with the hydraulic press. Is a guard on there so that you don't put your hand or anything in there. Or so just in case the metal kicks back, which I don't really see happening, but
yeah. And another thing we'll introduce here is a hydraulic bender. So you also can see the standard for the hydraulic bender. It only can go maximum thickness to 1/4 inch. And this is a piece of like aluminum angle we bend using the hydraulic bender. So here I will show you how I bend this piece. So everybody wear your safety glasses. Same as the shear pull to start. And there's a button saying up. Up. And take the wood blocks out. Then usually you need to lay out it first, like where you need to bend, and lay out it first, and go down slowly. Be careful though. So go down slowly and lay the bender to the line you draw in the metal sheet. So you see we bend it to 90 degrees. However, this is a piece of aluminum. So different aluminum, they have different standards. Like this aluminum, we bend it, it didn't break. So when you pick the materials, you need to be very careful what kind of material you want to use.
This piece is of wood for safety,
I think this wood just to hold the bender sink down, because it's a very old machine. Sometimes has some leaking, you can see in the ground. And so here has a oven shape thing. So we use this to melt some metals. For example, I think it. What's it called? I think it's a kind of like oven. Yeah, it's to melt the metal. For example, we melt the aluminum. You know, aluminum has like lower melt point, maybe about 660 Celsius. So when we need to make some mold, you can make a sand mold, and we pour the aluminum in to make any cast. Yeah, cast anything you want. So now you will see we have basically we have three kind of different welding machines in the lab. So which is this is a stick welder. So stick welding machine. We use so the electric goes through the stick, and you see outside the metal there has some coatings. So this coating will create the arc. This is called stick welding. And another one we have MIG. That blue machine is a MIG welding machine. So it comes with the gas tank. And anyone know like what kind of gas is it? What?
Inert gas. Inert gas welding.
Inert gas?
Inert.
Inert gas.
Like
This is argon. Yeah, argon. So we have wires inside, and when we do the welding, so the wire will come out, and this one has a gas. So the gas will shoot out from here. It creates an arc when we do the welding work. Another welding machine we use is called TEC. Anybody familiar with the TEC? TEC welding. So when we do the TEC welding, we usually didn't have like when we do use the other two like MIG or stick welding, you will see two pieces weld together, kind of welding beads you will see. But if you use a MIG welder, so the welding beads is very small. It's not like very easy to see. So you don't need to grind it after you finish welding. Also, when you use the TIG, you can like just melt two pieces of metal together. So yeah, same kind of metal you can melt same. It's very important when you weld two pieces together to use the same kind of metals, because different kind of metal has a different kind of specifications. Sometimes you see it's together, but it's not as strong as the same material. Yeah.
Very good.
Also for
What are these?
these,
Yes.
not very sure.
Cable
No,
carriers or
this
something?
is not for the cable. I think it's there is no cable comes through it.
This one here has a cable or no?
I don't know. Anyway, when you do the welding, also have a lot of safety you need to follow. Anyone give me some examples?
This one here?
Yeah, when you do the welding work, you need to wear the welding mask, and the shade should be bigger than 10. Also, when you do the welding work, the airflow is very important. So remember, turn on your venting system or in an open space. Also when you weld, try not to weld the two pieces of metal has coatings. So some of the metal has galvanized coating. When you do the welding work, the heat will the galvanized coating will vaporize, so it's toxic. Yeah. Any questions?
Any questions? You work with welding, seems, or metals. Very good. And you too? Very good. So that's all here.
Yeah.
Let's go outside a little.
Show your gasifier if you can.
Here is another question.
Gasifier, your gasifier.
gasifier?
Which you made?
Hey everybody.
This is a gas-fired go-kart I made. So basically, we try to use a gasifier. It's a downdraft gasifier, so we burn wood to start the gasification process. It will produce a syngas, and the gas try to we will go through the two different filters. One is the cyclone filter, another is just root filter, and then going to the combustion engine, try to run the go-kart. And I just clean the whole system and want to try to start it again very soon. Hopefully it will work.
Very good.